Howdy Optima. Any exciting news?
Hi Max. Yes, I actually have two exciting news for you.
Let me guess. One good and one bad.
Not quite, one great and the other one even better.
Sounds exciting. Let's start with the even better one.
All right. We are starting a new topic in the course.
Really, Optima? I am not sure I want to hear the other one now.
I'm sure you do. The other one will make you want to put that Superman costume on.
Break it then.
Check out this Indeed.com article on the most in-demand careers. Hint, look for your favorite number.
Number 7, Operations Research Analyst. Brilliant. News of the day.
I knew you would like it. Now, returning to the even better news. Aren't you interested in the new topic?
Okay, what's the new topic?
Integer programming.
Optima, are you sure this is an optimal way to spend our time? Integer programming sounds hard.
You are right, Max, it is not easy, but I promise, it will be worth your time. What were you going to do during the quarantine anyway?
Okay, you convinced me, you are very persuasive. So, tell me, what's so cool about integer programming?
Sure, I'll be happy to. If I start mentioning all the important practical applications, it will take me at least half an hour to just list them. This slide shows some. But you know what? I am pretty sure all those puzzles you couldn't figure out yesterday can be solved using integer programming.
Is it so? Then prove it.
Bring them on.
Okay, here is one. It says only geniuses can solve, and I almost got it yesterday.
You are so smart, Max. Let's try solving it using integer programming.
Sounds good, but what exactly is integer programming?
Integer programming is a methodology for solving optimization problems involving integer decision variables.
Is it like linear programming?
Not exactly. As you know, in linear programming all variables are allowed to have fractional values, whereas in integer programming some or all variables are required to be integer.
Why is that?
Well, you cannot manufacture 1/3 of a car, can you?
I guess not. So, how do we use integer programming to solve my puzzle?
We start by introducing decision variables. Looking at this puzzle, I think we should use logical or binary variables here.
Makes sense, because these seem to be perfect for representing yes/no or true/false alternatives.
Precisely. And in our case, we have 3 positions, each of which must be occupied by one of the 10 possible digits.
So, we should introduce 30 decision variables then, right?
I think so. Let's start by defining index sets for the digits and positions.
How about using D capital for the set of digits and P capital for the set of positions?
Sounds good. Then we can use lowercase d and p to denote the elements of these sets. Let's use variable x sub dp for each pair.
Right. Then x sub dp will be equal to 1 if d is the correct digit in the position p, and to 0, otherwise. For example, x sub 03 equal to 1 would mean that the third position is occupied by 0.
Great. Then our objective is to maximize the number of correct digits in the right positions, and the puzzle will be solved only if that maximum is equal to 3.
So, the objective is to maximize the sum of all the variables then, right?
Yes, Max, you got it. Let's write down the constraints. The first condition says that only one number is correct and in the correct position in the first row. This means that x61 plus x82 plus x23 equals 1.
Looks like the second constraint is going to be messy.
Not as messy as my hair during the quarantine, but you are right, it will not look as pretty as the first one. Let's write it down anyway. Since one out of the 3 numbers in the second row is correct but in a wrong position, this means that each of the variables x61, x42 and x53 is 0, and x62 plus x63, plus x41 plus x43, plus x51 plus x52 equals 1.
You are right, it's not too bad. Now I know how to get the constraints for the third row. Each of the variables x21, x02 and x630 and x22 plus x23, plus x01 plus x03, plus x61 plus x62 equals 2.
Next one is easy, nothing is correct in the 738 combination, so x7p equals x3p equals x8p equals 0.
And the last one is very similar to the second one, each of the variables x71, x82 and x030 and x72 plus x73, plus x81 plus x83, plus x01 plus x02 equals 1.
Okay, we wrote constraints describing all the 5 conditions. But something else is missing.
Yes, we need to write the constraint ensuring that each position is occupied by exactly one digit, so the summation of xdp's over all the possible d's equals to 1 for each p.
Excellent, we have finally formulated the model, so now we are ready to solve the puzzle.
Should we feed it to a solver?
We could, but let's analyze the model and see if we can get the answer by fixing the variable values based on the constraints. For example, from the second condition we know that x61 is 0 and from the fourth condition x82 is 0, so the first constraint now implies that x23 equals 1. So, we got one digit right. We must have 2 in the third position.
Now I am getting lost, too many numbers. How about creating a table of the variables that would store all the fixed values, so we can keep track?
Great idea. Let's skip the column for the third position because it is occupied by 2, and the rows for 2, as well as 3, 7 and 8, since we know they are all zeros.
This leaves us with a 6 by 2 table. Let's see if we can use some of the constraints to fix more variables.
I suggest we pick the low-hanging fruit first. Clearly, from the second condition, x61 and x42 are 0.
Also, from the third condition, x02 is 0.
Yes, Max, that's an easy one too. Let's see what else we can fix.
I think we are officially stuck. I told you, Optima, this puzzle is for geniuses, and I am not sure even you are in that category.
Not so fast, my friend. Patience is the key to success.
I think I found it. Look, in the fifth condition, all variables except for x01 are equal to 0, so x01 must be equal to 1.
Great job, Max. You are a genius.
LOL. Very funny.
Okay, now we can fill the rest of this column with zeros.
Let's check what remains of the second constraint after plugging in all the zeros.
We get x62 plus x52 is equal to 1. Also, x23 and x01 are both equal to 1 in the third condition, which means that x62 is 0.
So, x52 must be equal to 1 then. Yay! We solved it. We are geniuses.
I am a little worried about your mood swings, Max. Do you want to talk about it?
No worries, I just realized that integer programming is fun. Perhaps now I can solve my other puzzles.
I'm sure you can. Keep them coming.
Certainly. I've got some really fun ones here.